Hey guys, welcome to 2.2, Equations of Tangent and Normal Lines. Now, like we said last class, we can draw a tangent line to a curve that touches that curve in one and only one spot called the point of tangency. Now, the tangent to a curve at any point P is that straight line passing through point P, and its gradient is going to be equal to the gradient of the curve at P. So to find the equation of the tangent to the curve, you're going to calculate the y-coordinate of P using your given x in the equation of the curve. Then you'll find the gradient function for the curve, dy over dx, or the derivative. And then you're going to substitute your x-coordinate into that derivative to calculate the gradient of the curve, which is also the gradient of the line at point P. Then, using your x, y, and gradient, you'll use either slope gradient or point gradient form to write your equation. Okay, let's take a look at some examples. Point P has an x-coordinate of 2. I'm going to write that down. X equals 2. Find the equation of the tangent to the curve y equals x cubed minus 3 at point P. Give your answer in the form y equals mx plus c. So they're asking us for gradient intercept form. So here's what we're going to do. Step 1, find the value of y by plugging x into the equation of the curve. So I know that y is going to equal x is 2 cubed minus 3. Alrighty, let's evaluate that in our calculator. 2 cubed minus 3 is 5. So y equals 5. That's step 1 done. Next, let's find the derivative of the function, or the gradient function for the curve, y prime. And y prime will equal, remember we're doing n times a. Our n is 3, our a is 1. 3 times 1 is 3. And then we have x to the n, 3 minus 1. 3 minus 1 is 2. Our next term is a constant. So we know that constants will end up as 0, so that just goes away. Now, to find the gradient, I will plug in x. So my gradient equals 3 times 2 squared. All right. And 3 times 2 squared is 12. Now, I know we want our form in our equation in gradient intercept form, but it's easier to start out with point gradient and then convert over. So I've got my point, x and y, and I've got my gradient. So I'm going to do y minus my y value is 5 equals my gradient is 12 times x minus, and in my point, my x value is 2. Okay. So to convert over to gradient intercept, I am going to move the 5 by adding it to both sides. Y equals, and I'm going to distribute the 12. So 12x minus 24 plus 5. So then, the line that is tangent to the curve y equals x cubed minus 3 when x equals 2 is y equals 12x minus 19. All right, let's do another one. Find the equation of the tangent to the curve y equals 5x minus 8 over x at point 418. So here they've given me my x, which is 4, and my y, which is 18. All right. I also want to give my answer in general form. Ax plus by plus c equals 0. We are going to start out with point gradient and convert from there. So my first step is I'm going to rewrite this so that I don't have any variables in a denominator. And so I'm going to rewrite that y equals 5x minus, that becomes 8 over 1, which is just 8. And then moving my x up, I have to make its exponent negative. So 8 to the negative 1. From here, I can find y prime, which is the derivative or the gradient function, so that I can evaluate it at x is 4. My n is 1, my a is 5, and 1 times 5 is 5. X to the n, 1 minus 1. 1 minus 1 is 0. X to the 0 is 1. And 1 times 5 is 5, so we move on. Here, my n is negative 1. My a is negative 8. Negative 1 times negative 8 is just 8. And then I have x to the n, which is negative 1, minus 1. And negative 1 minus 1 is negative 2. All right, I'm now going to evaluate that to find my gradient. And my gradient is 5 plus 8 times 4 to the negative 2. Five plus 8 times 4 to the negative 2 is 5.5. I'm going to use the fraction 11 over 2 because this is a gradient. And I like to see my rise over my run. All right. Now, I'm going to go ahead and write this first in point gradient, and then I'll convert to general form. So y minus, my y coordinate is 18, equals my gradient and then x minus my x coordinate is 4. Okay, so to start converting this, the first thing I want to do is multiply everything by my denominator because I need to have integers as a, b, and c. So everything gets multiplied by the denominator, and I end up with 2y minus 36 equals 11 times x minus 4. From here, I'm going to distribute my 11 to y minus 36 equals 11 x minus 44. Okay, now I know that this needs to be written in the form ax plus by plus c equals 0. I also know that my x, my lead variable, my lead coefficient there needs to be positive. So I'm going to move y over here, and negative 36 I'm going to move as well. To move that y, I'm going to subtract it from both sides. To move the 36, I'm going to add it to both sides, which will leave me with 0 over here. And then I will have 11x minus 2y, and then I've got negative 44, but I'm adding 36. So I'm ending with minus 8. And there we go. All right, now that's finding the equation of a line that is tangent to the curve at a given point. Let's talk about the normal equation to the curve. So right there at that point of tangency for the tangent line, you can draw a straight line passing through P that is perpendicular to the tangent. So the gradient of the normal line must be the opposite reciprocal of the gradient of the curve. Remember that to find an opposite reciprocal, if your gradient is something like here, maybe 2 over 3, then to find the opposite reciprocal, this is positive, so we give it the opposite sign, which makes it negative. If it was negative, we would have made it positive. And then to take the reciprocal, we take the denominator and put it in the numerator, and the numerator and put it in the denominator. So that leaves me with 3 over 2 opposite reciprocals. All right, let's find the equation of the normal to the curve y equals x plus 2 squared at point 0, 4. Okay, step 1, let's write down our x and y. Our x is 0 and our y is 4. From here, I'm going to write out my curve equation a little bit better. So I know that x plus 2 squared is like saying x plus 2 times x plus 2. From there, I am going to FOIL. First is x squared. Outer is 2x. Inner is 2x. And last, 2 times 2 is 4. Now I'm going to combine my like terms. And so y is equal to x squared plus 4x plus 4. So now that I have that, I need to find the gradient of the curve so that I can find the opposite reciprocal and get the gradient for my normal equation. So, derivative or gradient equation, or gradient function, I should say, y prime. Let's look at my first term. N is 2, a is 1, 2 times 1 is 2, and x to the n minus 1 would be x to the 2 minus 1, which is 1, so I don't need to write anything. Next, n is 1, a is 4, 1 times 4 is 4, x to the n minus 1 would be x to the 1 minus 1, x to the 0 is 1, 4 times 1 is just 4, and then I have a constant, and as we know, constants go away because they will be equal to 0. From here, let's plug in x to find the gradient. So when x is 0, our gradient is going to be 0 plus 4, which is 4. All right, now I need to be able to write that as a fraction so that I can find the opposite reciprocal. But remember that any integer can be turned into a fraction by placing it over 1. Therefore, my opposite reciprocal, or OR, this is positive, so it needs to be negative. And I'm going to switch the numerator and denominator. So this becomes 1 over 4. Now I haven't received any direction on how to write the equation of the normal, so I'm going to use point gradient. And y minus, my y coordinate is 4, equals my gradient, negative 1 over 4. Now, I would usually put a parenthesis here and do x minus the x coordinate, but here the x coordinate is 0. Well, x minus 0 is just x, so I'm just going to write x. And there you have it. If you wanted to put this in gradient intercept form, you would simply add the 4 to the other side, and you would end up with y equals negative 1/4 x plus 4. Let's do another one. Point P has x coordinate negative 4. Find the equation to the normal of the curve at y equals 12 over x at P. Give your answer in the form y equals ax plus by plus c equals 0. All right, that y equals should not be there. Let's go ahead and get rid of that. Ax plus by plus c equals 0. which of course is our general form. All right, I am going to say that x equals -4. And the first thing I'm going to do is plug into my original curve to find y. And that's going to be 12 over x is -4. So y equals -3. All right, next step, let's find the gradient of the curve at x equals 4. So I'm going to rewrite y so that I don't have any variables in the denominator. That becomes 12 over 1, which is just 12. And to move x out of the denominator, I need to make its exponent negative, so that is x to the -1. All right, now it's time for the derivative. Y prime equals -1 times 12, or n times a is -12. And x, n minus 1 is going to be -1 minus 1, which is -2. All right, evaluating that at x is -4, we find that the gradient of our curve is found by looking at -12 times -4 to the -2. All right, let's look. -12 times -4 to the power of -2. And I find that I have a gradient of -3/4. Now, I'm looking for the normal to the curve, not the tangent to the curve. So instead of using this, I'm going to find the opposite reciprocal. This is negative, so my opposite reciprocal will be positive. And then I'm going to swap my numerator and denominator. So my gradient for my normal to the curve is 4/3. So starting out in point gradient and then moving into general form, y minus -3 becomes +3 equals 4/3 times x minus -4 becomes +4. All right, let's get rid of that denominator by multiplying everything by it. So I've now got 3y plus 9 equals 4 times x plus 4. Distributing that 4, the left-hand side is not going to change. 3y plus 9 equals 4x plus 16. Now I'm going to move both of these over to the right-hand side of the equation by subtracting them. So that's going to leave me with 0 equals 4x minus 3y, and then 16 minus 9 is plus 7. And there is the equation of the normal to the curve y equals 12 over x when x equals -4. Number 3, the gradient of the tangent to the curve y equals px squared plus qx at the point P 2, 5 is 7. Find the values of P and Q. Okay, so I know that X equals 2 and Y equals 5. Okay, I know that the gradient of the tangent to the curve is 7. So let me find the gradient function. Y prime. Okay, so I need to do n times a. N is 2, a is p. 2 times p is 2p. And then x to the n minus 1. X to the 2 minus 1 is 1, which is just x. And then here, n is 1, a is q. 1 times q is q. And then x to the 1 minus 1, we are left with just q. All right, now I know that this equals 7. So 2p times x, which is 2, plus q, make that look more like a q, equals 7. All right, so I'm going to multiply these. So I have that not 2. Where's my brain today? 2 times 2. So we have 4p plus q equals 7. Now, that in and of itself is not that big of a help to us. Goodness, I just cannot do these equal signs today. All right, that's not as big of a help to us right now. However, it's given us an equation involving P and Q, and we can get another one from our curve equation. Now, I know that 5 is y, and that equals p times x squared. Well, x is 2, plus q times x, which is 2. And that's just me plugging x and y straight into this equation. So I'm going to rearrange things a little bit. I know 2 squared is 4. So I'm going to write 4p plus 2q equals 5. And wouldn't you know it, I've got a little system of equations here. So I'm going to write this one here below. 4p plus q equals 7. And I'm going to use elimination to solve here by subtracting. 4 minus 4 is 0. That's gone. 2q minus q is 1q. I'm just going to write that as q. And then 5 minus 7 is negative 2. So q is negative 2. Then to find p, I'm simply going to plug in to one of my equations. All right, just writing out here in my final answer that q is negative 2. And then here, 4p plus negative 2 equals 7. So moving the negative 2, that means that 4p equals 9. Divide both sides by 4, and p equals 9 over 4. 9 over 4. Now, a great way to check your work here is to grab your calculator and do your equation of the curve right here. So P is 9/4 times x, which is 2 squared, plus Q, which is negative 2, times x, which is 2. And the answer you get is 5. So it works. And there are our values of P and Q. One more example. The gradient of the tangent to the curve y equals ax squared at the point 3b is 30. Find the values of a and b. Okay. I know that x is here, so x equals 3. So to find b, I'm going to plug in x, and I know that y equals a times 3 squared, and that is 9a. So I know that b equals 9a. So once I have a, then I can easily get my b. So let's find a. Now, I know that the gradient is 30. So to get the gradient, I'm going to do the derivative. Y prime is equal to 2 times a, which is 2a, and then x to the 2 minus 1 is x to the 1, so that's just x. So then the gradient is going to be 2 times a and multiplied by x, which is 3. All right, now I know that 2 times 3 is 6. So 6a equals the gradient, which is 30. Divide both sides by 6, and a equals 5. From there, I can just plug it in. So b equals 9 times a is 9 times 5, which is 45. All right, and there you have your values of a and b. That's it for the notes. If you'd like to pause the video here, you can do the practice problems on your own and then come back and check your work, or you're welcome to work along with me. Practice question 1. Find the value of x for which the gradient of the tangent to the curve y equals x squared over 2 plus x minus 3 is 5. Okay, I'm going to rewrite this so that I don't have a denominator under my x. So instead of x squared divided by 2, I'm going to write it as 1/2 x squared plus x minus 3. Okay, so from there, let's find the derivative or the gradient function, y prime. And my first step is going to be n times a. N is 2, a is 1/2, 2 times 1/2 is 1. I'm not going to write the 1 though because I will have an x, and so the 1 is implied. X to the 2 minus 1 is 1, plus my n is 1, my a is 1, and so 1 times 1 is 1. I am going to write that because x to the 1 minus 1 is x to the 0, which just equals 1. And then I have a constant here, which will end up as 0, so away it goes. Now, I know that in my gradient function, x plus 1 equals 5. Therefore, the value of x at which the gradient function equals 5, I find by subtracting 1 from both sides, and I find that x is equal to 4. So I need to find the equation of the tangent at this point. Well, x equals 4. So find y. I'm going to plug it in to the function for the equation for the curve. And I'll write my simplified one, 1/2 times 4 squared plus, again, x is 4, minus 3. So y equals 1/2 times 4 squared plus 4 minus 3. Y is equal to 9. And I know that it's a tangent, so the gradient of the tangent and the gradient of the curve are the same, and that was given to me as 5. So I'm going to write my equation in point gradient form. Y minus 9 equals my gradient, which is 5, times x minus my x-coordinate is 4. And there you go. Let's do another one. Find the equation of the normal to the curve x squared minus 1 over x squared at the point where x equals -1. Okay, so x equals -1, and immediately I'm going to find y, which is going to equal -1 squared minus 1 over -1 squared. Okay. -1 squared minus 1 over -1 squared. So my answer is 0. So y equals 0. Okay, now let's look for gradient. I'm going to rewrite my curve so that x squared is not in a denominator. So I have x squared minus 1 over 1. Let's just assume that it's 1. But this, bringing it up, is going to be x to the -2. All right, let's find y prime. Y prime is equal to 2 times 1 is 2. X to the 2 minus 1 is just 1. And then my a is -1 here, times -2 is +2. X to the -2 minus 1 is -3. All right, so then my gradient when x is -1 will be 2 times -1 plus 2 times -1 to the -3rd. All right, which means that my gradient is 2 times -1 plus 2 times -1 to the -3, -4. And remember that I can write that as -4 over 1 to make it easier to find the opposite reciprocal because I am looking for the normal to the curve. So my opposite reciprocal, this is negative, so this will be positive. And let's swap the numerator and denominator to get 1 over 4. Okay, now let's write our equation. Y minus, my y coordinate is 0. Y minus 0 is just y. So I've got y equals my gradient times x minus my x coordinate, which is -1. Minus negative becomes positive, x plus 1. All right, good job, guys. I'll see you next time in 2.3, rates of change. Have a good one.